This is our video for Unit 9, Day 5. This is the last video for the unit and last video for the semester. What we're talking about today is all the different types of probability we've talked about so far, but now using tables for those types of probability. So tables are a very common example used in probability problems. One thing to remember about tables, unlike with the dice or the cards, is that tables represent results. So they're an example of experimental probability, but not theoretical probability. Another word for experimental probability is empirical probability. So the kind of table you see here below, this is called a two-way frequency table. Right, and the reason is because there's two different sets of categories represented by the different rows and columns. So it can be a little confusing at first to understand what each thing represents. So we're just going to kind of break down all the different parts of the table. So first thing is tables usually will have a title or something introducing you to what the table is. And it's a two-way table, so there's always two different sets of categories that divide the data. So dog versus cat owners, that's going to be our first category. And everybody falls into one or the other of those categories. And we have the same thing with our rows. Left-handed versus right-handed is our second category. And what we're going to do now is talk about what each of these different numbers here represent. So at the end of each row or column, that represents the total number who fall into that category represented by the row or column. So we're going back to the table above to do some examples here. This 55 would be the total number of left-handed people in this survey. So this would be the left-handed total. This is in the row for right-handedness, so this would be the right-handed total. This is in the cat column, so this would be the cat total. And this 76 is in the dog column, so this would be the dog total. Right, so the ends of each rows and columns represent the total for that particular category. So if we add up the numbers from the four middle boxes, or either of the two category totals, which we just talked about, that will give you the overall total. So how many total people this is out of, and that's found in the bottom right-hand corner. Right, so 133 people here took this survey. That's our overall total. And again, that is located in the bottom right corner. Sometimes this will not be given to you, so you're going to need to add it up for yourself if it's not given, or fill in the missing pieces. So now we're going to talk about the middle boxes. Each of the middle four boxes represent the intersection of two of the categories. So these numbers fall into both categories. That's what the middle represents. And that's one of the reasons we use this for probability so often. It's so easy to see what the intersection is. So for an example, if I looked at this 34 here, this would be the intersection of left-handed and cats. These people are both left-handed, and cat owners. So now we've gone through a little bit what each of these different numbers represents, how the table is set up. We're going to do some examples together, and you're going to try some on your own after this. So first thing is number one, find the probability, experimental probability here of a person being left-handed in this survey. So that means what I'm going to look at is I'm going to look at the left-handed total out of the overall total. So going back up to the table, right, this would be my left-handed total 55, overall total 133. So probability of 55 out of 133. Same idea for number two, we'd be looking for the dog total out of the overall total. Again, go back up to the table and find those two numbers. The dog total is located right here, the 76. Overall total is still 133. So 76 out of 133. Now these middle two involve two different types of probabilities. So this symbol right here is called the union. This is a symbol we use to represent or probability. So anyone who falls into either of these categories, so right-handed or cat. So we look for anyone who falls into either one of those categories out of the overall total. So go up the table and take a look at who would fall into either one of these categories. So it's right-handed and it's cat owners. So if you look at this, this person is right-handed, so he falls into that category. These 23 people are right-handed and cat owners. They fall into both categories. And these 34 people are cat owners, so they fall into the category. This 21, the left-handed dog, these are the only people who don't fall into that category. So these three are what I'm going to use here for my union, for either or. So I'm going to add up that 50, 55, 23, and 34 out of 133, our overall total. So we'll add that up. 55, 23, and 34. 5 and 3 is 8, 4 makes 12, 1 and 5 is 6, 2 is 8, and 3 makes 11. So we have 112 out of 133. The next symbol we've seen before, this one is the intersection. And intersection means both. So now we're looking for those people who fall into both categories out of the overall total. And this one's a little easier to see because this is where the row and the column intersect. So where the cat column and the right-handed row will intersect. So if we look at this column and this row, here's my intersection right here. These 23 people. So it's 23 out of 133. So these last two are both examples of conditional probability. This symbol right here, the vertical slash, is what we use for conditional probability. With conditional probability, we always look for the probability of both over the probability of just the given event. In this case, we're going to look for both, so the intersection of left-handed and dog owners, out of the given event, which is always the second event, which is just going to be the dog total. So if you look back up at the table, this would be my intersection for left-handed dog owners. Right, they're both left-handed dog owners. They fall in the intersection of the two categories, so that's 21. And then we look, in this case, out of just the dog total, so that's our given event. So it's going to be 21 out of 76. Now the next problem looks similar, but the difference is we changed the given event. The second event is always the given event with conditional probability. With that notation. So here we're still going to be looking for that same intersection. Now we're looking, instead of the dog total, we're looking at the left-handed total. So 21 is still that intersection, and our left-handed total is 55. So that makes 21 out of 55. So this is all the types of probability we've talked about so far, just now we're using a table instead of using dice or decks of cards as our examples. So on the back of this sheet, here's some problems for you to try on your own. If you're having trouble with this, ask some questions, or you can look up some other resources online on conditional probability. Um, conditional probability and two-way tables.